All right, I'm back at it. It's your boy. Okay, here I'm some little cards on it. Yeah, I'm some little cards. Okay. Uh, let's get back to it. Let's just get back to it. I don't know what's happening, but let's get back to it. Okay, let's read our statement here on this question. This question two. This question I was given by this learner from this technical school. I don't know the name of it. I don't know the name of it. Yeah, but it is. I don't remember actually. Yeah. So okay, they're doing the same thing as we do. It's physics. Yeah, it's physics, guys. It's physics. Don't be scared. These are not hard questions like that. You just need to use what you know in order to tackle these questions. And don't be scared. Be confident. Always be confident with what you are doing. And make sure that you know the key points. You know what I mean? Grab those key points. Physics is not really that hard. I don't think it is hard. I don't think it is hard. That's why I took it in high school. I don't think it is hard. I don't think it is hard. You just need to. Okay, I don't know. Okay, let's go. Okay, Paul is putting a suitcase with the mass of 10 kg at a constant velocity. She pulls the suitcase over a rough horizontal surface with a force F of 50 Newton at an angle of 60 degrees to the horizontal. So, okay, yeah, you can see him pulling a suitcase at an angle of 60 degrees. Okay, so and it looks like she's going to the right. To the right. You can see that, ne? She's going to the right, guys. She's going to the right. Okay, so let's go back to our statement. Poe is pulling a suitcase with a mass. We have mass given, which is 10 kg. Ne? So, at a constant velocity, just know that your acceleration will always be zero here because the velocity, if a Vf, it is equal to her Vi. A final velocity is equal to her initial velocity. As in, like, okay, let's say, for example, this person is going to the right at a velocity of 10 meters per second. One is going to the right. So this is a Vi of a initial velocity. So by this term, constant velocity, by these words, by these whatever, they are saying they are basically saying that her initial velocity is equal to her final velocity, as in, like, it is the same throughout a journey. You know what I mean? It's the same throughout a journey. It means a Vf will also be 10 meters per second or one. So, and our acceleration is the rate of change of velocity value. And as I've said before, like, the definitions in physics are your formulas. The definitions in physics are your formulas. So, okay, our acceleration is the rate of change of velocity. Is the rate of change of velocity. It means, okay, it's change of velocity over change of time, which means on our change of velocity, our Vf is equal to our Vi, which is 10 minus 10 is Vf minus Vi. It's the same thing. Divide by the time she took to travel to travel from from an initial position to a final position. So okay, so it means 10 minus 10 is 0, and any number divided by a 0 okay, any numerator that is 0. Okay, let me say a 0 numerator divide by any number or anything is 0 or 1. Here the time, we said the time she took for F to go from position 1 to position 2 or 1. That's the thing. So it's just that at that time, if it can be, maybe she took 2 seconds or maybe 3 seconds, It's like 0 divided by 3, which will be 0. Our acceleration will be 0. It is always 0 here. That's what they basically mean. So okay, state Newton's first law of motion in words. Okay. Oh, damn. Okay, let me try. I get a value. We are here to teach one another, to remind one another. So okay. Our Newton's first law states that unless a resultant force is acted upon that object, the object will remain in its state of motion. It means that if it was at rest, it will remain at rest unless a resultant force is acted upon that object. So that's when it can move. So okay, let's go. Hey, this phone, I think it is tripping on me. It is giving me some colors I don't really understand. Okay, but okay, let's go. I've stated Newton's first law of motion in words. So okay, name the non-contact force acting on the suitcase. So you need to know the non-contact forces and the contact forces. You just need to know. But force of gravity, just know that it is always a non-contact force. You know what I mean? It is always a non-contact force. It doesn't change the direction. It is not really influenced by anything. It is always acting downwards. You know what I mean? It is always acting downwards. I would say you can influence those ones, see the frictional force, see because you apply a force, so you can see that. So, but it is always the same. Force of gravity is always the same, and it is a non-contact force. So, okay, calculate the coefficient of friction of the frictional force on the suitcase. Okay, let's go. They're saying calculate the coefficient of friction of the frictional force on the suitcase. Were we given a frictional force here? It is not given. It is not given. We're only given a applied force. Yeah, only given the applied force. It's okay. Let's do this. Let's try to look for the forces that are acting on our suitcase, ne? So, in order to find value the coefficient of friction of the frictional force on the suitcase, you need to use this formula. When they talk about frictions, use this formula. This is for the kinetic frictional force. It's Fk because it is in motion. It is moving. It is accelerating now. It is not at rest. So, if maybe it was at rest, that's when we were gonna say like Fs, static frictional force. Even on this coefficient, was gonna say the coefficient then S one, like yeah, like that. I just don't know what this thing mean. I don't know, but it's the coefficient of what of frictional force. So okay, let's look for the forces that are acting on our on our suitcase. So okay, there is the applied force, which is 50 newtons. Okay, 50 newtons at an angle of 60 degrees. It is going northeast. You can see that. So you can see, and it is inclined. It is inclined valley. So okay, the force of gravity is acting valley, and the frictional force it is like there already, because we know that this thing is moving. The kinetic frictional force is already there because we know that this object is moving. So okay, because our force applied now, it is at an incline. Let's try to find the components of our force applied. We already know that we'll have Fy and Fx. These are the forces that follow the principle of either perpendicular or parallel to the surface. You can see we have Fy, which is perpendicular to the surface, Fx, which is parallel to the surface. So these ones are following the rules. So okay, let's try to calculate this thing. Okay guys, okay, what's together ne? What's together? So okay, whether we don't know the normal force, and we don't know the frictional force. We don't know the coefficient of friction. So what do we do? Let's try to use that formula. F net is equal to ma. So all right, it is said that she's pulling the suitcase at a constant velocity, which means our acceleration is 0. So F net is just the sum of forces acting on our horizontal, because we're looking for the normal force. One. So already we know vele on our vertical uh, direction, the acceleration will always be 0. On our vertical direction, the acceleration will always be 0, because this thing, it is pulled horizontal, it is going on a horizontal surface. One. So okay, our F net is pointing upward, our Fy is also pointing up. Don't leave these Fy, also include it, because it follows that rule, that principle of either perpendicular or parallel to our surface. So Fn plus Fy and then minus Fg. Fg, it is opposing, it is opposing our positive direction, so it will be negative Fg, which is equal to 0. As I've said, acceleration is 0, so then anything multiplied by 0 will give us 0. So Fn then plus our Fy, we have our force applied. Don't forget the trigonometric ratios. Don't forget the trigonometric ratios. For Fy, Fy is our opposite, and for our opposite we use this rule. Sine, we're already given the angle 60, which is equal to sine is opposite. What is our opposite? It's Fy. Our Fy is opposite to the hypotenuse, which is 50 newtons. So then it's sine, our sine rule is opposite over hypotenuse. Hypotenuse is our 15, eh? So then you do the cross multiple. 50 sine 60, which is equal to, so 1 multiplied by Fy, if Fy. So in place of Fy, you just put 50 sine 60, because you already have the value of Fy. Now you already have the value of Fy, you can see that. So minus, so Fg, you know that Fg is equal to mg, which is equal to mass. Our mass of an object was what? It was given, it was 10 multiplied by, this one doesn't change, it always stays the same. And then you find your Fg. You find your Fg. In place of Fg, I've put the mass multiplied by force of gravity, which is 9.8. So Fn, so we are adding 50 sine 60. Okay, it's 50 sine 60 minus 10 multiplied by 9.8. It gave me negative 133.24, which is equal to 0. So then you will transpose 133.24 to the other side, and then it will give you a positive number, which follows our rule, because we took our Fn as a positive, it is going upward as a positive, and then our Fy will also give us a positive number because it is going upward. So okay, we have our Fn, our normal force. So okay, let's come again. Let's come again. Let's go. Therefore, Fx, now we're going to our horizontal forces. Mara, yeah, I think I took a long route. I think I took a long route. Yeah, but then okay, but then you can see, okay, you can see the way we did it. But okay, it means that this one does not really need to be done. You feel me? You can't do this because we don't have. That's why I'm saying, guys, we're teaching one another. You know, now I've realized the mistakes. I've realized that I took this the long way, and I shouldn't have done that. But I've showed you like some procedures on how to do certain things. Okay, now you'll know. So okay, very agree. We found our normal force. So if we were given our frictional force, it was gonna be easy for us to calculate our coefficient of frictional force, because it was gonna be F kinetic frictional force divided by our normal force, and then we are going to get our coefficient of frictional force. So okay, here is the correct one. 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 You can see this is the correct one. The simplest way to go around this thing. The simplest way to go around this thing. Yeah, guys. Hey, okay, okay. Now it all makes sense, because this thing, yeah, I think, yeah, I thought this thing long time ago, but then, yeah. Now I remember what happened. Yeah, we are right. We are correct here. We are very, very much correct. We are very much correct. Because we have found our normal force, which is 133.24 newtons. We have already found it, so it means we have already found our our normal force. Guys, I'm allowed to make mistakes, ne? I'm a human being. So okay, let's go forward. We have already found our normal force. Okay, so let's go. Now let's find our Fk, our kinetic frictional force. I get it. At first, we dealt with our vertical forces, ne? All of these forces that were acting vertical. So now let's go to our horizontal forces. Let's go. Which one? Okay, now. So we're taking to the right as positive, and then to the left as negative. So then here is our force that follows the principle of either perpendicular or parallel to the surface, because this one is parallel. You can see it is parallel to the surface. So it's Fx minus Fk. Fk is opposing our motion, so it will be Fx minus Fk, which will be equal to 0. We're still using that formula. It's just I didn't really put it here, but okay, let me do it so that you don't get lost. It's F net, which is equal to ma. You know that any number multiplied by our acceleration is still 0. Doesn't change. Still 0. So okay, our F net is Fx minus Fk. You feel me? So okay, so Fx is Fx. We can find Fx. Let's go back to our free body diagram. So okay, we can find Fx. Fx is an adjacent. We use this rule in order. Okay, our 60 degrees is already given. So it's cos 60, cos a certain angle is equals to an adjacent over hypotenuse, and our adjacent here is Fx over what is our hypotenuse, which is 50, our given applied force. So now let's do the cross multiplication so that we can find our Fx. F1 multiplied by F is Fx, which is equal to 50 multiplied by cos 60 is 50 cos 60. We already have the value of Fx. So okay, let's go and apply that here. You can see it's 50 cos 60. So let's transpose Fk. Let's take Fk, a jumper, our equal sign to the other side, and then this, it changes the sign. Now it becomes positive. So when you press your calculators 50 cos 60, it gave me a negative value. So this is my direction. This negative sign is my direction. It means that our kinetic frictional force is acting opposite to our motion. It is acting to the left. I get it. We took right as positive. So I went further and said Therefore, 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 Fk is equal to 47. Okay, let me just write it like this. Is therefore Fk is equal to 47,67 newtons to the left. That's our direction. So now let's get back to our formula in order to find our coefficient of the frictional force. Let's get back to it. So okay, here we do our calculations. So as I've said, when you want to find your coefficient of kinetic frictional force, you just say Fk divided by the normal force, and then it gave me 3, 0 0,36. Here this one doesn't have scientific units, because you are dividing a force with a force. You are dividing a newton with a newton. It's basically newton divided by newton, and then they cancel each other, these ones, so then it doesn't have SI units. So alright,